I don't have any of the panels, let's say, from
All right, so where are we?
So this is the Atlas control room.
Yeah.
So from here, the whole experiment is going to be operated at one point. So if you look around, we're going to have these 15 operator desks, and each is dedicated to one of the sub-detectors that you have already seen down in the guided tour.
Oh yeah.
And these are exchangeable, so you can just go in front of one of these operator positions and log in with your name, log in with your functions, and then you get the programs and the controls for you.
All right.
And in the beginning, we're also going to have additional satellite control rooms, how we call them, which are experts sitting in a nearby room. So in the beginning, we're going to have here 15 people sitting here, maybe 2 people at one operator, so 30 people. Roughly 30 people in the control room for the beginning, and another same amount of people in expert control rooms sitting in front of dedicated PCs, checking temperatures, checking voltages, analyzing the data on the fly. So this is...
So it looks like it's running Linux?
Yes, we are running Linux, Scientific Linux 4.
Scientific Linux 4?
Yeah, it's a public version based on Red Hat Linux and can be downloaded from the net for free.
Yeah. Do you know if there's a lot of engineers optimizing the Linux for, especially for CERN, of course? Yeah? I mean, this is huge.
No, this has to be safe for controls of big experiments.
Safe, so there's no hackers outside who change. That's not a problem.
That's always a concern, but I mean, I'm not going to talk about safety network policy because I'm not an expert on this. But I mean, of course, we have a dedicated network inside the Atlas pit, or the Atlas the point one, with a gateway to even to CERN. So I mean, we're separated from the normal CERN network.
But here we're just on top of Atlas, kind of. No, we're just by there. So why it has to be so close by? Why does what's the reason to be so close to the control room? It has to be closer. It's better. What's it called? The cables are closer. You have to be close somehow, or
in principle we can be anywhere.
Yeah.
I mean, so for example, the whole LHC ring. With all the magnets, also our magnets at Atlas, is actually controlled from one operator room, the CCC, how it's called. And I mean, as soon as you connect your equipment, which you want to control to the net, you can be anywhere. But of course, you want to have a crew locally here in case of any problems. In
case of a problem, to go there or something.
Problems in the sense of that you have problems in the readout of the electronics, or so, not in how to say it, not in intervention in case of an emergency or so. But I mean, for example, the main computer farm, the level 2 and level 3 trigger is just in the next building.
Next building, so is that where the grid is starting, or something like that?
The grid is something completely different.
Completely different.
This is a CERN project, well, a worldwide project where the CERN is included, which is not directly connected to Atlas. Atlas will, in the end, need the grid technology to distribute the data and the power of the to use the processing power of this to analyze the data.
That's not what you see on the screen is here.
No.
That's not what you use. You don't use the grid.
This is separated,
Separated.
So the grid will then be used for if the data that has been stored to analyze this one. Here we are concentrating on taking the data.
Yeah.
So this is the next step.
You were saying something about you're entering some kind of phase. What did you say? Not phase 1, but something is coming up. You said next week or something like that. Is that? Did you say something about this control room area?
Yeah.
You think we can film those screens, or can we go there? Okay. All right. So there are 2. What did you call them? Each of them are control
operator stations.
Operator station.
And here you have somebody working on the data acquisition.
Nice.
The TDAC software. You can all look up this on the net. Just go to the public web page. You'll find the links to all the
software.
The software, to the working groups, to the sub-detectors.
All right. So the computers controlling four screens for one computer?
Yeah. One computer is connected to 4 screens. The computer is actually in a air-conditioned building next door, so it's roughly 80 meters away from here.
To keep it cooler, or no? What do you mean air-conditioned?
This is for noise mainly.
Noise.
The noise in the control room is reduced.
So
I mean, we're talking about rack-mounted PCs, high-powered dual processor. So these machines are pretty noisy.
All right.
And here you would have 50 machines in the control room. Would not be a nice environment to work with.
All right. So there you're kind of what do you call it? Controlling the different parts somehow. This is the what you call control room, of course.
It's a control room.
Yeah.
Yes.
So you control the parts somehow. That's not where you get the results and all that, and where scientists might discover something. Is that not really the part? That's just controlling the engineering, or was that also the part?
I mean, this is mainly for the data taking. Of course, you have a monitoring. You monitor the quality of your data. You see if the detector is fully operational, for example. You always check if all voltages, all temperatures are correct, if the detector is in the optimal conditions, or if it's some parts are under maintenance or have a local problem at the moment. So and this you supervise from this room.
All right.
And
so
the real analysis of this data will then be done offline in things like where we need things like the grid for this.
All right. So people working in this area are from all over the world in this control room, and specialists in
each sub-detector sends the people, trains them,
specialists,
trains them as shifters, and sends them to the control room.
All
so this is really the heart of the operation.
The heart of Atlas. All right.
Of the operation.
It kind of looks like, you know, when there's a control room for a spaceship, you know, but it's a different thing. It's just underground. But so engineers, computer scientists, and all that.
What you see here now is this wall will be painted white, and we have going to have beamers projecting the interesting things on the wall, so every station can export what they want to show to the other operators on the walls. We have the prototype beamer has already been installed. It's just under maintenance at the moment. So
something you just tested recently. So how soon is it going to work in full scale this area? When the Atlas is finished, that's when it's really starting. Is this year, right?
Yeah. Soon.
All right, soon.
For us, soon.
So how long time has those computers been up, or is it just recently, or is it kind of a long time?
Roughly, can't remember actually. Roughly half a year in this order. I mean, we started with 2 prototype machines, only on a normal desk. At one point, we upgraded to 5 machines. Then we got the nice furniture. So this is a slower evolution process. I mean, this is and of course for computer you always order them at the latest possible moment, because you don't buy a computer now which you will need in a year's time. You get a lot more for your money if you buy them in a year.
But you can replace them, get them replaced. If I mean, of course, just upgrade that will. I mean, it's not like
no, but I mean
upgrading the Atlas. The computers can be upgraded when there's new dual 4 cores and whatever.
And this is also foreseen that they are regularly upgraded.
Yeah.
I mean,
this is the plan. All right. So maybe you would even upgrade them before Atlas launches, or you don't think so? For example.
We hope not.
Okay.
No, I mean Atlas is already operational in large extent. I mean, we have of course we don't have a beam from the LHC at the moment, but I mean the detector is operated with cosmic radiation already. So I mean they are taking data in a kind of sense.
Cosmic radiation?
Muons.
Muons is already going in there.
Yeah. This is the normal background radiation that we live in.
All right. So can you just explain just a little bit about the beam? What is that actually? What is a beam? Because
the beam, when I say beam, this is the the 2 proton beams in the LHC are going around the circle, which Sandra has already
so it's
explained
possible to just send beams somehow.
Well, you accelerate protons.